Hi folks, welcome to the first of the chapter 3 videos. And so in this video, we're going to take a look at sample space and all the vocabulary and the basics of probability involved in that, okay? All right, so in this example, we have a sample space S, and in this sample space, it consists of all the ordered pairs of two whole numbers, okay? Now, the first number is going to be from 1 to 3. And the second number is going to be from 1 to 4, okay? So what that means is our sample space is going to be sort of two numbers here, okay? And in the first spot, we can choose from 1, 2, or 3. And in the second spot, we can choose from 1, 2, 3, or 4, okay? So that's basically what we're going to be looking at in this example. All right, so let's start off with part A. Part A says find the sample space. And so find the sample space means we want to list all of the ordered pairs that have a first number that's 1, 2, or 3, and a second number that is 1, 2, 3, or 4. Okay, so let's kind of list these in a systematic way so we don't get too lost. And so I'm going to go ahead and list like 1, 1, 1, 2, 1, 3, 1, 4, right? So all of those have a first number of 1, and then I went through all the pink numbers, okay? And now I can go ahead and list the ones that start with a 2, so 2, 1, 2, 2, 2, 3, and 2, 4. And then I'll go ahead and list all the ones that start with a 3, and so we'll have 3, 1, 3, 2, 3, 3, and 3, 4. Okay. And so when I look at this, I've got all the numbers that have a 1, 2, or 3 in the front, and then a 1, 2, 3, or 4 in the second spot. All right. Now, for purposes that'll become clear in just a little bit, let's count how many of these we have so we kind of know how many values do we have in the sample space. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so I'm just going to make a note for myself here that I've got 12 things in the sample space. Okay. All right. Part B says, suppose that event A is wherever the sum is even, list the ordered pairs in event A, and then determine P of A. And P of A really means we're looking for the probability of A. Okay, so let's list all the pairs where the sum is even. Okay. And so that means if I take the two numbers and I add them, I get an even number like 2, 4, 6, 8. All right. So I can see that 1, 1 has that, 1, 3, and then 2, 2, 2, 4, and then 3, 1, and 3, 3. Okay. And I'm going to list those all out for what we have for event A. So 1, 1, 1, 3, 2, 2, 2, 4, 3, 1, and 3, 3. Okay. And then it says determine the probability of A. And so to find the probability of A, we need to find out how many times this happened, and then we're going to divide it by how many things were in the sample space. Okay. And so if I count, I've got 1, 2, 3, 4, 5, 6. All right, so 6 out of the 12 times we ended up with something that when I added the two ordered paired numbers, I got an even number. Okay, so what that means that our probability is going to be 6 over 12, or we could say 0.5. Okay, all right. So let's take a look at part C. It says, suppose the event B is whenever the first number is prime, list the ordered pairs in event B, then determine the probability of B. So it's going to be very similar to A, except we're listing different things. Okay, this time we want to know when that first number is prime. And so prime numbers Turns out 1 is not a prime number. Prime numbers are like 2, 3, 5, 7, 11. So any numbers that just have 1 and that number as its factors, okay? So let's list all the ones that are in event B, okay? So where's the first number prime? So it's not going to be any of these because those all start with a 1, but everything here, those all start with a prime number. So all of these are actually going to be in event B. All right, now I'm going to cheat a little bit. I'm just going to go ahead and, I'm just going to go ahead and copy and paste this. All right, so these are in here. And if I think about my probability for B happening, how many times do I have this? 1, 2, 3, 4, 5, 6, 7, 8. And 8 out of 12 times. All right, so 8 over 12, or we can think about that like 2 over 3, or as a decimal, 0.6 repeating. Okay. All right, let's take a look at part D. It says list the ordered pairs for event A and event B. Okay, so what that means is we're going to look at event A and event B and see which ordered pairs are actually in both of those. Okay, and I'm going to go ahead and highlight those in pink, the ones that are in both of them. Okay, and so I noticed that 2, 2 is in both of them. I noticed that 2, 4 is in both of them. I noticed that 3, 1 is in both, and 3, 3, 3 is in both, okay? And so how many of those are in both of them? Well, that's 4, right? And so what that means then is that the probability of having A and B is going to be 4 out of the 12 that we had to begin with, or we could say that's 1/3, or as a decimal, 0.3 repeating. Okay, now I'm not going to write these out. I'm just going to sort of highlight this here, that all the ones in pink above are the ordered pairs for event A and event B. Okay. All right. Part E looks super similar, except it says list the ordered pairs for event A or event B. Okay, so that just means all the things that happen in all of them together. And they could repeat, and that's okay, but they don't have to. Like, they might just be in A and not in B, or they might be just in B and not in A. Okay, so let's see. I know that these 4 are already in B. All right, so I've got 8 in B plus these 2, the 1, 1 and the 1, 3 that had an even sum, but they're not in, they don't start with a prime number. Okay, so how many do I have altogether? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. Okay. And so I have the 10 ordered pairs. Why don't I go ahead and maybe underline those in the blue so we can kind of keep track? All right, so it's going to be all of these and the 2 in the A that I didn't already get in B. Okay, and so because I have 10 of these all together, the probability of A or B is going to be 10 out of the total of 12, okay? Or we can say 5 over 6. And if we wanted to turn that into a decimal, we do 5 divided by 6, and we get about 0.83 repeating, okay? So we can see that the probability, like the chances we're going to get something in A or B, is much higher than the probability of getting A and B. And that's going to be something that we find true in general, where if it's like and, that's like more specifications, probably going to have a lower chance of happening. But if it's or, we're more flexible, it could be this or that, we're going to find that that probability is higher. All right, let's take a look at these last 3. We're introducing some new notation. So I just want to make sure that's something we understand, okay? So it says list the ordered pairs in B, and then there's like a little boop, and we call that a prime, okay? So B prime means things not in B, okay? In other words, B is is whenever the first number is prime. So now I want to think, when I go back to my beginning sample set, how many of these, or which ones they don't start with a prime number, okay? In other words, which ones did I not grab for B? Those are the ones in B prime, or we say the complement of B, okay? So if I go back to here, to get B, I just chose the ones that started with a prime number, and the ones that I didn't pick were the ones that started with a 1. So what that means is that the ones in B prime are the ones that we didn't pick initially, okay? So in other words, B prime is going to be 1, 1, 1, 2, 1, 3, and 1, 4. And if we think about how many times that happened, it happened, let's see, P of B prime is 4 out of a total of 12. And so that could be reduced to 1/3, or we could say 0.3 repeating, okay? All right, let's try and use this notation again in part G. It says find P of A plus P of A prime. All right, so we already have P of A from earlier. We said that P of A is 6/12, or 0.5, because we had 6 where when we added them, the sum was even, okay? And so I know that P of A is going to equal 0.5, okay? Now, let's go ahead and find which ones weren't in A, okay? And I'm going to go back and count how many of those there were, and I'm going to find that probability. Which ones are not in A, that's what that little prime means. All right, so let's see. Which ones do not add to make an even number? 1, 2, 3, 4, 5, and 6. I have 6 of them that don't add to make an even number, okay? And 6 is really 6 out of the 12, which means that P of A complement is also 0.5. And so this question says, find the sum or add them together. And so we're going to just get 1. Okay. And now it turns out that that's true every single time. Every single time you have a probability of something happening plus the probability of it not happening, it's always going to be 1. Okay. So if you think about like, what's the probability that you are going to eat breakfast today, let's say, all right? And what's the probability of you not eating breakfast? Well, either you are or you aren't. So altogether, that probability is just going to be 1. Either you're going to eat breakfast or you're not going to eat breakfast, but there's not really an in-between. So our probability of A plus the probability of A complement is always going to be 1. All right. All right, last but not least, let's talk about this notation. And I know that your textbook gives formulas, but I want us to really think about, like, what does it mean, okay? So if someone says find probability of A with this line B, what it means is in B, okay, which ones are also in A. All right, so we're going to go to the B set. We're only going to look at the B set and then figure out which one of those are in A. Okay. All right, so let's go to the B set. And of these, let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. Of these 8, how many are in A? Well, we have 1, 2, 3, 4. So it's not 4 out of 12 because we're not looking out of the whole set. We're just saying 4 out of 8 of these, okay? And so when I come back down here in B, which ones are also in A, I get that the probability of that is going to be 4 out of 8, or we could say 0.5. Okay. Let's do it the other way now. Okay. So this right here, P of this B bar A means in A, which ones are also in B. Okay, so now this time we're going to go to the A set. All right, so our probability of B given A. And in our A set, there were only six ordered pairs. Okay, so I'm going to put 6 on the bottom because I'm already starting in A. So I only have 6 to count from. How many are also in B? Okay, so let's go back up. In A, of these 6, which ones start with a prime number? Well, 1, 2, 3, 4 of the 6. Okay. Since 4 of the 6 start with a prime number, we say the probability is 4 over 6, or 2 over 3, which is 0.6 repeating. Okay. All right, so hopefully, let me get this all on one page for you. Hopefully this was a good practice exercise to talk about a lot of the vocabulary terms in 3.1, but if you have any questions, let me know.